Okay, so guys, last time we finished talking about stacked data structures, and so in this video we're going to start talking about a new type of data structure called singly linked lists. And singly linked lists are based around this concept of nodes. And what we want to do is we want to try to create a chain of nodes by connecting them with one another. And this might sound a little complicated, but I think once we start going through the code and I'll explain the concept a little more in depth. I don't think it's not really a hard concept. And so what we're going to talk about in this video is we're going to talk about what a node object is and what it consists of. How can we initialize the singly linked list class? And then we're going to talk about two functions, the append function and the print list function, each of which has its own function or its own method that we're going to talk about. And so before we go on, first I want to talk about what a node is. A node is basically an object that consists of a data and next element. And so the data element is going to hold a specific value that maybe we can print out, or it's just the data value and data element of the node. And the next element is going to point to what the next node is, and through this we'll be able to loop. This is how we connect each node to one another, and we're going to be able to loop through the singly linked list. And so if we take this list as an example and look at this first list, what we're saying here, or not this first list, this first node, what we're saying here is that the data element of this first node is the string a, right? And so we know that if we were to print out the data element of this node, we would print out a. And the next element for this node is going to be I'll make this more specific, the node that holds the data element b. And so what we're saying here is this node holds the value of a. The next element of this node is the node that holds the data value of b. And so the next value is really pointing to what the next node is. It's not, although it might look like it in this, it's not really pointing at the next data value, it's pointing at the next node. That next node will hold the data value, but it's not necessarily the string. And so I hope that made a little sense. And so basically if we loop through this whole list, what we're saying is that this node holds the data value of a, and it's pointing to the next node that holds the data value of b. And so if we go to the next node, we're going to land at this node. This node, like I said before, holds the data value of b, and it's pointing to the node that holds the data value of c. And so if we go to the next node, this node holds the value of c, and this points to the next node, which holds the data value of d. And one thing you need to note is for the very last node, that the next value of that node is going to point to none. It's not going to point to something else, because this none indicates that this is the end of the list. And that's really important, because if you don't do that, it may just end up being an ongoing list that never ends. And so you'll see when we code out the print list function, having this none is important so we know when the list ends. And so when we reach this last node, we're saying the data value or the data element of this node is the string d, and that the next element is none. It's not a new node, but it's none. And so this is going to tell us that it's the end of the list. And so if we want to initialize the node object or the node class, what we want to do is we want to take in a data parameter. And this data parameter is going to let us obviously give a data element or initialize the data element of that specific node. And so what we can do, we can say self.data is equal to data. And for now, we're going to say that self.next is equal to none. And we're just doing that for now. We're going to change this later on, but for now it just keeps it simple. And so yeah, we're going to initialize the data element with the parameter that we're given, and we're going to say that the next value or the next node of this specific node is equal to none. And so, like I said before, this is based around the concept of nodes, and having self.next in each node allows us to connect one node to another. And so when we want to initialize a new singly linked list, we're going to have this whole list, right? Where do we start? Well, we're going to have to start at the beginning. And that's really the only item we're going to have to, or really the only element we're going to have to initialize the singly linked list with, because since we have since we have the next element within each node, we're going to be able to use that to loop through every single node in this list. And so with that, all we need to know is what the head element is, or the first element is, so that we can just loop through everything using that next element of each specific node. And so we can just do that by saying, when we initialize our list, we want to say that self.head is equal to none, because this is going to initialize an empty list. And once we start appending stuff, we can change this value so that we have a first value, and we can start looping through several nodes, or how many ever nodes we need to, starting off with this head value. But for now, we're going to make it equal to none, so that this is going to be an empty list. And so this is how we initialize our singly linked list and our node. And so what we're going to do now is we're going to create the append function. So what this append function is going to do is, if we look at this code right here, over here, I made an instance of our singly linked list class. And so what this does is it's going to call this init function, and it's going to set the values or the elements of this list right away. And since all we've done is we said that the self.head, the head value of this list is equal to none, this is going to initialize an empty list within the class. And so right now, when we only run this line of code, it's just going to be an empty list, right? Initializes an empty list. What we want to do is we want to append nodes to the very end, so that this list actually has nodes inside of it. And so if we do that, if we have an empty list, we want to, well, since we have an empty list, we want to make sure we handle for both cases where the handle for if the list is empty, right? If the self.head is equal to none, and we want to handle for if the list is not empty. If self.head is equal to something, we want to be able to loop through and get to the very last node, so that we can then append our new node onto that last node. And so these are two different cases that we can handle for. And right off the bat, we can, the first thing we need to do, we need to create a new node, right? Because since this is a chain of nodes, when we append to our list, we want to make sure we append a new node, not just a string, or else it's not going to work. And so what we can do, we can call this new node, literally just, we can call a new node, and we can call the node class and pass in that data element. And so if we look at this append function, what we're saying is we're passing the string a, and that's going to be passed right here. It's taking it as a parameter, and we're using this parameter, and we're sending it as a parameter to the node class. And remember, what we're doing in the node class is we're taking that parameter in the node, and we're setting the data element of that node object equal to the data parameter that we took in. And so hopefully that made sense. But all we're basically doing, we're taking this string a, and we're just setting the data element of this new node equal to that new data that we passed, which in this case is the string a. So once we've created our new node, now we can start handling for appending to the list. So if the list is empty, there's not going to be a self.head, right? And so what we can say is if not self.head, which is basically saying that if the self.head is equal to none, what we can say is self.head is equal to the new node that we created, right? Because this new node is going to be the only element, and it's going to be the very first element. So we can just say that the very first element, or the head element of this list, is going to be equal to that new node, and just return right there, right? So if we run our code, we can just run or actually we'll run our code after. What I want to do first is, first we'll handle for the list not being empty. So hopefully I'll just run through this one more time. If the list is empty, what we're saying is there's not going to be the self.head is not going to be equal to anything. It's just going to be equal to none. And so we're saying that if the self.head is equal to none, we're going to set our new node equal to the self.head, and we're just going to return right then and there because we know we've already appended, we don't have to do anything else. Now if the list is not empty, what we're going to say is that we're going to say cur node is equal to self.head. Since there's a self.head, we can just make a new parameter based off that, and we're going to say the cur node is equal to self.head. And the reason we're doing this is because we're going to loop through every single node using the next element of those specific nodes, and you don't want to really be messing with the self.head. And so what we do, we just make a new variable that holds that value, that holds that head node, and we're just going to be using the cur node to loop through instead of using the self.head node, because it's just better practice to leave the self.head alone and use this new cur node because it's not really going to be messing with anything. And so we can say while cur node dot next, we can say cur node is equal to cur node dot next. So what we're saying here is if our list already consists of, say, 3 values, what we're saying is we're starting off at our self.head, which is the node that holds the data value of a, and what we're saying is this is going to be our cur node, right? Since our cur node is equal to self.head, this is our cur node. We're saying that if this cur node has a next element, which in this case it does, it's pointing to the node that holds the value of b, we want to loop through and say cur node is equal to the cur node dot next. And so what we're saying now is that the cur node is not going to be equal to the node that holds a, it's going to be equal to the node that holds b, because this node, because the node that holds a is pointing to this node that holds b. Once we're on this on this node that holds b, this is a new cur node. We're looping through here again, and we're saying that if cur node dot next exists, and so we're saying if the b node points to something, which in this case it does, it points to the node that holds the value of c, we're saying that cur node once again is going to be equal to cur node dot next. And so we're saying that now, instead of the cur node being the node that holds the value b, it's going to be the node that holds the value of c. And so we're going to loop through, go to the next node, and now we're at the node that holds c. And now we're back at this while loop again, and it's testing. And now it sees that cur node dot next does not exist, because the next node after this node of c is equal to none, which doesn't exist, right? And so we're saying that now this cur node is going to be, we're telling our program that this is the last node, and since there's not a node after this, we can simply end the while loop, and now we know that our cur node is going to be equal to our last node. And now what we want to do is, if we're passing, say, a data element of c, we want to append our new node right here, right? Which in our example would probably hold the data value of the letter d. And so this is going to be our new node. We're going to append it after the node that holds the data value of c. And then what we're going to say is the next value of this new node is going to point to none. And so because of this, now we have a new list where our new node is at the end at the very end of the list, right before the node value of none, which doesn't really exist. And so what we're going to say is, since cur node is now at the very end, we're going to say cur node dot next is equal to the new node. And with that one line, what we've done is we say the node that holds c is going to point to the new node. Since the next value is pointing to the next node, the node that holds c is going to point to the new node, and based on our node class, this new node is going to be pointing to none, right? Which is what this none is here. And so now we know that this value after next is equal to none. And so that's the end of the list. And right then and there, we've handled for the list not being empty, and we've appended our new node at the very end of the list without making sure that it doesn't go past the none value and that it's before it. And so now what we want to do before we can run this is we want to create the print list method so that we're able to print this out. And we're going to use a similar concept. What we're going to say is current node is equal to self.head. And so this is why I was saying before that you probably shouldn't loop through the self.head and make self.head is equal to self.head.next. Because if we do that, you start messing with where the self.head is, and instead making a new variable that holds that self.head value. It doesn't mess with the self.head, but we still have that node value. And so I hope that made sense, but basically what we're saying is or if maybe this will help. If we have a list right here, we know that our self.head is equal to the node value that holds a, but we don't want to keep looping through and saying that the self.head is going to be equal to the b, and then the self.head is going to be equal to the c, because that's going to mess with where the self.head is. Instead, what we're going to do is we're going to say the cur node is equal to a, right? Because that's what we're saying here. We're setting the cur node equal to self.head, and so the cur node is going to hold the first node, and then we can loop through by saying cur node is equal to the node that holds b, and so on until we get to the end. And so while we're doing all this, the self.head is still going to be equal to the node that holds a, and so because of this, it doesn't mess with the self.head while allowing us to loop through every single node in the list. And so I just want to let you guys know that's why we did that here. And so in order to print the list, we want to start off at the very first element. And so we're going to say cur node is equal to self.head. And we're going to say while cur node. So this is going to loop through every node until it gets to the none value at the very end. While cur node, we're just going to print out cur node.data. We're just going to print out the data element. And then we're going to say cur node is equal to cur node.next. And so like I was saying before, this is going to allow us to go to the next node and let us loop through that chain of nodes. And this is literally just going to print out the data element. And so in our case, it's going to print out those strings that we initialize our node objects with. And so with this, we are done with our print list and append methods, and we can just test them out really quick. So we initialize an empty list. I appended a, and I'm printing it out now. And so if I run this, let me clear all this first. If I run this, it prints a right here, right? And so just a quick recap, what we did when we printed out, when we called the append function the first time, the list was empty, and so we set the self.head is equal to that new node. This new node was a new node object with the data parameter that we passed. And since we said the self.head is equal to new node, that's all we need to do, because this new node is then going to be pointing to none because of this next value. And so when we printed it out, we said that the self.head is equal to a, right? That's the self.head is equal to the node that holds a, and so the cur node is going to be equal to the node that holds a. And so while cur node, we printed out the data element, and we moved on to the next we made cur node equal to the next node / value. And since that next value was pointing to none, this returned a false, because none a new node, the next node doesn't exist since it's none, because none technically doesn't exist. And we finished this while loop, and we're done with this function. And so that's why it only printed the a. And so if we add another one, if we append a b also, this should just print out AB, and indeed it does. And so in this case, what we did was the list was not empty this time. The list was not empty this time because we appended A the first time. And so what we were saying now is current node is equal to the very first element, which is self.head. We loop through to the very last element, and then we said that the next element of that last node is going to be equal to the new node that we created here. And since that new node is already pointing to none, we don't have to do anything about that. And so when we printed it out, we said that current node is equal to self.head. We loop through everything. We printed out A, move to the next value, printed out B, move to the next value. And so since this B node was pointed to none, we finished this while loop, and that was it, and we printed out AB. And so now we can create multiple ones. We can add anything. We could do D. You could even do B again if you wanted. And if you run this, it's going to print out everything just the way you wanted. And so that's it. That's the append and print list functions. I hope this was a good introduction to what nodes are and simply linked lists. And I hope to see you guys in the next video.